Greetings, class. We're looking at Chapter 6, Section 2, still working with confidence intervals, but in this case, we don't know the standard deviation for the population. In Chapter 5 and even Section 1 of Chapter 6, we knew that we had to know the standard deviation for the population. We either knew that the initial population was normally distributed, or we knew we had more than 30 in our sample size when we were doing a sampling distribution. But in this case, we don't know the population standard deviation. And when that happens, we can't use a Z statistic or a Z distribution, the normal one. We have to use what's referred to as the T distribution. And on page 310 of your text, it gives you the definition of a T distribution, that the mean, median, and mode are equal to 0. It is bell-shaped and symmetric about the mean. Again, the area under the curve is equal to 1. However, the tails are thicker than those in the standard normal distribution. And it depends on what they refer to as degrees of freedom in the particular set. Typically, the degrees of freedom is the sample size minus 1. So if you're looking at with degrees of freedom, you'll notice that as you get closer, as you get further away from the mean, that there's more area between the x-axis and the curve for a degree of freedom of 2 than the standard normal curve. But after we get close to 30 degrees of freedom, like sample size of 31, then the T distribution begins to approach the standard normal distribution that you would see. But for today, we're going to work problems that require us to find a T, critical values of T associated with various levels of confidence and then confidence intervals. So I'm going to go ahead and look at some exercises in 6.2. So we're going to find the critical value T sub C for the level of confidence and sample size N. So we're going to go over to our StatCrunch software. We're going to go to Stat, and we're going to do a calculator, but this time it's not going to be a normal calculator because we don't know the standard deviation for the population. We have to use a T calculator. Now, on the T calculator, you'll notice that it asks you for the DF, or degrees of freedom. Just like with the Z calculator, the normal standard normal calculator, we're going to look for area between. Now, since N is 10 in number 1, N is 10, the degrees of freedom would be 10 minus 1, or 9. 1 less than your sample size. The area under the curve is determined by our value for C, which in this case was 0.90. So I type the area under the curve in based on the C value they give me, and I click compute. And you notice that it is symmetrical, just like the normal curve, although this is a T distribution, and it says that it's from negative 1.8331 to positive 1.8331. So the C value to 2 decimal places would be 1.83. So in my stat lab, they'll either ask you for 2 or 3 decimal places, so it could be 1.833 if they wanted you to round it to 3 decimal places. Now, if you want to find a confidence interval, remember when we knew the standard deviation for the population, we did Z-stats. But when you don't know, when the standard deviation is unknown, you have to do a T-stat one sample with summary. So this one was a one sample T. Now we still have to know the sample mean. Let's look at problem number 9 here. The sample mean is 12.5. We need to know the sample standard deviation, in this case 2.0. And we need to know the sample size, in this case n is 6. And we're doing a confidence interval for C equals 0.90. So I change this to 0.90. I'm going to store it in the data table and then click compute. And you will see that our lower limit is 10.85 to 2 decimal places, and the upper limit is 14.15. That 5 makes this 4 become a 5. And so if I were putting this in in my stat lab, you would see a parenthesis, and then you'd see a box for the lower limit. Then you'd see a comma, and then you'd see a box for the upper limit. Now, they may have you round this to different numbers of decimal places, but the confidence interval here is 10.85 to 14.15, rounded to 2 decimal places. And what this means, since my C value was 0.90 or 90%, then I am 90% confident that the true population mean, mu, is between 10.85 and 14.15. We used a summary for the first T statistic. This time we're going to look at a set of data rather than the summary. Notice that there are only 12 values here. We know that the population is normally distributed, but we still can't do a Z statistic for confidence interval because we don't know the standard deviation of the population. And there are fewer than 30 of these, 30 sets of data, so we're still going to have to do a T statistic, to a critical T value, to find the confidence interval, and we're going to want a 99% confidence interval. It does ask us to find the sample mean and the sample standard deviation. So let's go ahead, and I'm going to do number 25 because it will upload itself into StatCrunch for us. So I'm going to click on the little icon. Oh, it didn't. Okay, so we're going to copy to clipboard, and I will do a Control-C. I will open my StatCrunch back up, and I apologize because I thought it was going to open in StatCrunch for me. I'll open a new data table, and I will paste, Control-V, paste into StatCrunch. So I have a column of data that I will now use. I'm going to go ahead and find the sample mean and standard deviation. So those are summary stats for a column, variable 1, and I want the mean and, mean, and then I'm going to hit the control key and standard deviation. I'm going to put it in my data table. I'm going to click compute and close the window. So the mean to 1 decimal place is 910.3. I'm going to check that answer. Okay. The sample standard deviation, this is for the sample, it's not unadjusted, it's regular standard deviation, 305.1 to 1 decimal place. And we will check that. And now we're supposed to construct a 90% confidence interval for the population mean mu. Again, There are 12 pieces of data here. Even though the population is normally distributed, we don't know the population standard deviation, only the sample. So we've got to use the t-stats, one sample, but this time it's with data because our data is in column 1. Now, I'm not going to do a hypothesis test. I want a confidence interval, and I want it at the 90% confidence level, or 0.90. I'm going to store it in my data table and click compute. And it says that my lower limit is 7.52.2 rounded to 1 decimal place. So my lower limit goes on the left, 752.2, and then my upper limit, 1068.5, goes in the upper limit box, and then I'll check my answer there, and those are correct. So you don't actually have to know the mean and the sample mean and the sample standard deviation to do this in StatCrunch, as long as you have a column of data, because when StatCrunch did the t-stats with the data, it knew that it was able to calculate the mean and standard deviation in order to determine the lower limit and the upper limit for your confidence interval. I did want to bring your attention to a flow chart on page 314 of your e-text. It says about using the t-distribution as opposed to the standard normal distribution. It asks you, is sigma known? Is the population standard deviation known? If you do know it, like we did in section 6.1, if the population is normally distributed or n is greater than 30, then we can use the standard normal distribution so that we can use critical values of z. So we would run the z statistics. If you don't know sigma, then either the population must be normally distributed or your n must be greater than or equal to 30. So it's important that they tell us the population is normally distributed for some of these problems. However, and this is the important one, notice in the flow chart that when both n is less than 30 and the population is not normally distributed, you can't use either the z statistics or the t statistics from StatCrunch. You wouldn't be able to work the problem at all. So this little paragraph right below that flow chart is extremely important. I hope this helps you with chapter 6.2. Please feel free to contact me if you need assistance.